Right. So, the second to last talk of the day is a good friend, Harri Porten.
Yep.
Please welcome.
Yep. Yeah, hi. You will see an embarrassing mistake I made when handing in the abstract for the talk. I'm of course not an insurance salesman. I wanted to talk about assurance of software quality, so don't expect me to provide some solution for a few euros per year that will solve all your quality problems. What I rather want to talk about is what I have gathered during my professional experience of the last 12 years now, as our company froglogic is focusing on software quality. And we are not invading how the customers do their quality stuff, but of course we see what they do in a good way, what they do in a bad way, and what we see is that they don't know when to stop and what to prioritize. And I want to talk about that because testing is an expensive thing. I'm not saying it's more expensive than development, designing, etc. But the question is, how expensive will it get in the end? Because you can endlessly test your software and still not be very sure about whether you have found all bugs that are in there. So I want to show a little bit how to reduce your efforts or how to make it easy. And since we're here at the Qt conference, I want to focus on something that is also especially becoming problematic for UIs because they have so many states they can assume. So a user can always click somewhere or use the fingers to a gesture, etc. And this opens up a lot of combinations. They can easily explode until they become unmanageable. And I want to show you how you can deal with that. And I'll do so by doing a short demo. Oh, sorry, I should stop. And I will use an example application that I took from the Qt examples. Oh, let's take another one. And that is a wizard, QWidget application, but same is true for Qtml. It's a simple wizard that allows a programmer to define a C++ class deriving from QObject or QWidget. You have a few settings here. There's another tab where you can make a few settings. And then there's a third one where you can enter even more. And this looks innocent, but if you think about this from a testing perspective, there's actually quite a few things to cover. I'll show you a simple UI test done with our tool, but no matter how you do the testing, as a unit testing framework, writing JavaScript in Qtml or C++, it doesn't matter, it's always the same concept. I'll first show you a single run through this wizard where I filled out some fields and ran to that. That was pretty quick, right? But it was a small demo application. But how many fields have there really been? Look at the entry fields here. User could enter everything. Here the checkbox is easy, it's on and off. A radio button has a choice. These are also okay. But if I add up all the possible combinations, so I've put a list up in the top, the name could be anything. I'm just choosing 3 different ones that are representative. Maybe I choose 2 different possible base classes, whether the QObject macros there is on and off. There are 3 different kinds of constructors, and comments, header, protection, and include statement are all optional. If you multiply all of that, you're reaching 288 combinations, and I did generate them here in a table. And it's pretty long, so I will not press the execute button here because then the day will be over, basically, at least if you have a more complex application. And there's one thing that some people came up with, is saying a bug doesn't depend on all the 100 input parameters your application might have. It's typically just 2 things that have to come together to show a bug. Of course, there are cases where there are 3 or 4, but they're becoming less and less likely. And that's why you can do an n-wise testing with 2, 3, or 4 elements together. And the most prominent one is pairwise, and pairwise testing is a fixed term. And for that, you only want to ensure that each configuration parameter is at least exercised in a pair somewhere in the test set. So for example, there is the class name C together with a base name B, or class name C with my base, etc. So in this table, you'll find a lot of combinations, and each pair is guaranteed to be there once. And there are some free tools that you can download to generate those tables. Some of them are more efficient, some are not. But from getting down from 288 cases to 11, means I can run this test in a reasonable time. At the end, there should be some check, of course, whether the wizard created the right source code. I've not done that here. But beware of weaknesses. I chose some sample names, but are they good? I don't know. What happens if a user tries to enter a class name with a space in it? That's not going to compile. So already my reduction contains some assumptions that might prove fatal in a real world application when a user can enter everything. Okay, but let me, no, we're not over yet. One way around that is that you might have heard the term monkey testing. So you assume that someone wildly taps or clicks on your application, enters data, and you see what's going to come out of that. Similar to that, it's also about random stuff, is fuzz testing or fuzzing. That is more about data, while the monkey testing is about performing actions. In this case, you're trying to just feed some stream or file and see how the application reacts. It might crash. These boxes mean to say there's typically a black box approach taken, so where you do that from the outside. So a hacker, for example, wanting to intrude somewhere is most likely going to have a black box unless the source code is available. If you do testing internally, you have the white box possibility and look at the structure of your application and check how far did the monkey get or how far did the fuzzing get. And I'll show this as well. Both of them. The monkey test, for example, here, JavaScript, there is a loop that normally runs endlessly, but I was afraid that I cannot stop this while I'm doing the demo here, so I've put a maximum number of 30 iterations in it, and it's going to be about an address book application. There's also an old Qt example where the user can click on the button and enter data. And let's see what the monkey is doing with it. So it's opening the thing, clicking at wild elements. Oh yeah, I feared that it's open a file dialog and it's creating some directories on my hard disk. So if you have such a monkey and there's something really dangerous where the system could be deleted, you better use a virtual environment that you can restore later. Yeah, and that people keep running that for ages and ages to see what happens. And similar, this is done with fuzz testing. And I asked one of my colleagues to try this on the Qt meta object compiler to see how far with fuzzing we get into the application. And we calculated that in terms of code coverage, so how many statements were executed. And on the x-axis, there are the iterations. And what we started with were purely random characters. So we created files, asked mock to parse them, and see what happened. Of course, it found a lot of errors because this wasn't valid C++. But after a while, things got better, and we roughly reached 12% coverage after 1,000 iterations, which isn't so much. So there are some security companies selling you tools like that for 30,000 euros, and you might have to run them for days or weeks until you find a remaining bug in the application. But that was really dumb. More intelligently is if we start using C++ keywords already, because mock is about C++, so if we have if, class, protected, and whatever, it's more intelligent, and you see that higher coverage levels were reached right away. Still, this didn't really develop into something that is serious C++, so the files still looked very much like garbage. So the better approach that many people take is to start with an original C++ file. This was qwindows.h, and then we started to permutate that. And you see the initial coverage was already much higher, and it's still rising, so we didn't let this run for much more than a few minutes. And there are some tools that also deal with grammar of the tool, HTTP, SOAP, or whatever. And there's also a genetic way we played with that. So we took the best cases, merged them again with each other, changed them. So we had an evolutionary approach which was even going up higher than these. Okay. Since we were really given just very few minutes for this talk, I have just noted a few items about Qt's quality assurance on one page. There's the code reviewing that takes place, and there's another session in parallel to this one, so if you rather wanted to hear about code review, I'll skip this here. There's a CI system, so there are batches of changes that are proposed. There's a build test, the unit tests are run, and only those that pass those tests are accepted in the Qt repository. Could be done by Jenkins or anything else. There's a dashboard, which those who are interested in then can look at. So there's the status of all the different package builds done by the Qt company. And if you want to write your own tests, you of course know about Qtestlib, which has been there for many, many years. There's also a Qtml test runner with a test case element that you can use. And something that is still very much hidden and maybe only known still to the old-timers, if you're implementing your own QAbstract item model, and everyone who has already done that knows how painful this can be, there is somewhere deeply hidden in the Qt repository a class model test which will test your model implementation and, with some sanity checks. And this usually always finds bugs because it's pretty strict and it's doing things you as a tester of your application would not have noticed when you just open some data in a table, for example. And what we are doing is also nightly, every night, provide a report of how those tests in the CI system providing coverage. I can later show you that page for those of interest who are interested. Okay, but I promised something how to deal with the complexity, with this explosion of the possibilities. There are some guidelines which I still see many people not following. I've seen testers starting their tests from A to Z without prioritizing at all. And maybe they stopped somewhere at F and the release had to go out and they had tested the least important features of all. So just prioritize this for yourself. What are customers typically using? What does your tutorial show? So do those parts that are present in everyday's use of your application and not some esoteric thing like printing out something somewhere in your office. One other easy thing to do is to look at the incoming bug reports. There have been some very good research projects showing how many bugs have been reported against Mozilla and also some company internal ones. And yeah, one has to say an application that is, or part of your application that is old, that might be bad, but doesn't receive any new bug reports. So maybe it has good quality or simply not enough people use that to really make a difference in terms of bug reports. So I would focus on the hot ones. And then there's one thing, I think Microsoft pushed that a lot, that is code churn. So they started checking how much does your project change. And they found out that this was actually a very good indicator to see where bugs happened. And let me think of this tool, yeah. Churn, that is a utility written in Ruby, which you can download from GitHub. And I'm asking it to check all the changes that were done with it in the last month. And I just listed a few. There are other ways you can configure it, and I think it's also rather specific to Ruby, so it doesn't understand C++ code really. But it was telling me that there have been 6 changes in the GDB engine.cpp file, and so on. Most likely they are the bugs, so that's pretty well proven if you look at software projects. And what I also noticed that there has been no work on tests at all. So if I were that group's manager, I would look at those things, try them out, and have a good chance of finding bugs that way. Other thing, code metrics, very old, popular, and sometimes very meaningless. But I'll show you how you can still make some good use out of that, and I'm going to use the KD SOAP libraries that's implemented by KDAB. There's a client and a server for the SOAP protocol, and I will use the tools which is also free, which is called CCCC, that's C++ code count, and I will ask it to generate a report. I will tell it which directory to scan or which files. And since it prints out some error message we don't need, I'll hide them for now. And you'll see it has found those files, and it has generated a report, which we will look at. And I'm not going through all of these numbers you see here. So you recognize lines of code, and McCabe is really mentioned quite often there. Some others which I had never heard of before. There's individual statistics on the classes found. Some object orientation checks. And yeah, we've seen some that were also flagged as critical. But I don't want to propose this as the way to find problematic parts of your code. And some developers will simply disagree that 10,000 lines in a file are a problem, and they might even be right. What is much more useful is if you rather monitor changes in those metrics over time. So if you run this today, run it again next week, and see that something that was harmless before suddenly turned red or yellow, whatever, that means something has happened there. And that is also an area I would suggest to focus on. And there's a very good paper from some Microsoft researchers who have done that for a Windows Server release, and they found a great correlation to changes in those metrics to the bugs that were filed against Windows, while the absolute numbers don't have any correlation at all. Okay. Yeah, code coverage is the other thing, and that's the final thing I'll show you now. Code coverage is about finding out which parts of your code have been reached by your tests, manual tests, unit tests, UI tests, whatever, and there will be usually some colored view on it, some summary at the end, and I'll go a bit into detail about this. And you have to know that there are different coverage levels. I've sorted them in the way that is typically considered to be a hierarchy. You can measure coverage of functions. So what's the function called? Lines or statements, branches or decisions, which are somewhat the same, or some people consider them to be identical. There is decision and condition coverage. DC is the abbreviation. Conditions are Boolean expressions, so A or B. It will verify that both A and B have been true and false. There's a modified condition and decision coverage that's mandatory in aerospace, for example. And there are some others like multiple condition coverage, path, loop, and so on. But I would say that in the norm, if you're talking about Qt programming, only those here in this main part are relevant at all, because these others will be impossible to reach with a real-world Qt application, which has those UI events inside and other things. So Qt itself wouldn't also get high coverage metrics on these esoteric ones down there. Yeah, and to give you some advice, I've listed the popular tools that are out there. The most famous classic one is Pure Coverage, which was acquired by IBM. I recently found out that they have been selling that to some of their partners, and I fear there's not much maintenance going on. It's probably just selling some support contracts. GCOV you know if you're using GCC. It has some weaknesses for optimized builds and parallel builds and so on, but since it's free, I won't talk bad about that. There's Testwell, there's Bullseye, there's the Cocoa product from our company, but yeah, freely choose. There are probably more, but I'm not aware of any of those others supporting more than one platform, actually. So you might be trapped if you're using something that is not working on Linux, for example. Okay, so what is special if we think about Qt applications? I'll mention one example. If you're using QWidgets or derived from QObjects, there's the QObject macro. That's just one line for the programmer, but in reality, it will expand to something big as this, and you see there are other macros in there which will again expand. So it will reach to a lot of code, and is it really relevant that all those functions are tested? I don't think so. So I would filter that out to avoid getting false negatives in terms of coverage, and we are actually doing that by default unless you turn it off. These will not be flagged as uncovered if they are not used. Other specialty about Qt is, of course, QML. That's a completely new thing, so what to do about that? We have a prototype of that is also covering the JavaScript, and I know that one of the Qt Creator developers would also like to add that into Qt Creator itself, and we have been talking to him, but it's probably still takes some time, as he told me today, because it is a quite complex project after all. So I think we'll still eventually release it later this year or next year. But Qtml is something special because it has some JavaScript in it, but what about the rest, the UI? And what we did there, just for fun, is also doing UI coverage, and I have not seen this before. We are checking whether each menu item, button, etc. is being used. So these are colored green because this drop-down menu was used, but others are not used. Also some style checks are done. So this is taking UI and coverage to a new way of thinking. And finally, I will show you some live demo of how to do analyze code coverage, and I will use this KDE SOAP library for that. And yeah, I'm in that directory, so I built the application in an instrumented way. And one thing I can do now is to execute the unit test that the developers have added there. So now it starts executing those, and they are using that Qtestlib library, which I mentioned before. They're going through some classes of the server and the client library. Won't take much longer. And as a result, or rather, let me do it this way. What our tool is doing there is to create some execution files which contain data from all those test runs. And since I want to all analyze them in one, I've written a small shell script that copies them together. And let's look at how this project is being covered. So there are a set of unit tests. And first thing you see, maybe you can't read it from the back. So there's some coverage of 30%. Here, the functions and classes are listed. You're, of course, free to define for your own company what do you consider to be good and bad. So these are just standard values of medium, good, and bad coverage. Here's the coverage for files. Here are the individual test cases. And looking at those, I was looking for cases which are interesting and might be coverable through a unit test, and I've found that there is a helper class, especially for Qt 4 support, I believe, which has date time, including a time zone, and this looks perfect. 100% coverage. I could even jump into such a file here, and everything is green. But one thing to be aware of, it really depends on how close you look, because we have just been looking here in terms of line coverage or statements. But if I now switch the highest to the highest level, which is also about decisions, we suddenly see, what was green before is suddenly becoming orange. So obviously there is some problem with the coverage. And I look at one or two of those cases, and you see here was a case where each line was covered, but looking at the analysis of that, it says this if was always true and it was never false. So looking from the lines, it was perfect, but why is there an if statement if it never, actually the other case happens? Actually, the if statement is fine. This is protecting against a self-assignment. What I, in this case, then would do is that I'll add a new unit test. Oh, no, that's the wrong file. I located this before, so here the class is tested, and I will do a self-assignment. I'll assign this variable to itself. That shouldn't crash or anything. I'll also verify that its value is still correct, and let me go into this directory, rebuild the test executable, and I'll run it again. Everything has passed, and now let's check how the coverage has changed. Remember, here this operator had just 75%. I'll reload the, I don't know whether that's the right directory here. I don't know. this file name here might be wrong. Oh, no, sorry, I have to go to the test directory. Basic. So I'm loading that. I saw that the test has passed. That's an information I can give. This is the self-assignment test. I'm importing that data, and that's done. And now this function is at 100% as well. And that's how you can proceed. Just as I said, concentrate on the important parts. With coverage data, you can also do other things like finding out the optimal execution order, because some tests will give you more coverage than others. So if you're short on time for a CI system, maybe just execute a few of those, compare what tests give you in addition to others, and so on. So there's a lot of things to do, and I hope that I gave you a little bit of insight or inspiration to do stuff like that yourself. Okay, I'm done, and I'd be open to questions that you have.
Snacks. Hands in the air, and I'll bring you the stick. You can talk into it. Yep.
Yes, you mentioned the continuous integration. How do you see the integration with tools such as Jenkins, for example? In a build machine, you have that. How do you see the integration with this tool?
I think all of the coverage tools have some command line interface, so it's possible to do that. And for Jenkins, there's a special format EMMA XML that's coming from the Java world. And what we do is just to print out this format, and then it's possible to use a Jenkins plugin to display that. And I think it's a good thing to do to monitor the coverage over time. Actually, what we have found out now is that coverage of the Qt project is going down. So we have to verify whether these are some test failures or that are indeed less tests are written than code has been written. Okay?
I have a question on kinds of tests will be analyzed, because you can have unit tests, you can have GUI tests, you can have some functional tests, you can have some performance tests. Which kinds of tests will be analyzed by this tool? So which calculates?
Okay, no, this tool will measure whatever is done to execute the application. So if indeed performance tests, etc., would also count for that, or let's say you send an application to your customers or some beta testers and see how much did they use your application, and or if you're outsourcing your testing, you might also get feedback on how good the outsourced testers have been using your application. So coverage is really independent from the test method, I would say. It doesn't always make that much sense as with unit tests and functional tests, but still it's possible. Okay, anything else? Otherwise, I'll still be up at our booth and available for a talk here as well. Okay, thanks.
Thank you very much.